Hi, hello. A very welcome to all of you in this session. So, we really hope that all of you are safe and well. I am Rajiv here with you to take class science physics part. Let's begin. So, in class 9 science in physics portion, there is a 5 chapter is there. Motion is the first chapter, then force and laws of motion, gravitation, work and energy, and sound. So now, today we will start the first chapter, motion. Let's go to the next. So in this motion chapter, today what we will learn? We will learn the state of rest with examples, definition of rest in physics, state of motion with examples, definition of motion in physics, and lastly rest and motions are related. These are the things today we will learn. Okay, next slide. Now, as the chapter name is motion, so there is a pictures, there is some images are there. Different types of motions are here. One is rectilinear motion, one is circular motion, one is rotational motion, and is periodic motion. So the question always comes in your mind, if there is a different types of motions are here, so what do you mean by rectilinear motion? So from the figure also you can understand, that means linear motion. Rectilinear motion means linear motion, means one-dimensional motion, means the change in position in only in one direction, maybe x direction, maybe y direction. As for example, moving train on the railway track. So these are the examples of rectilinear motion or linear motion, or you can say one-dimensional motion. So if it is example of one-dimensional motion, so the question maybe comes in, what do you mean by two-dimensional motion? Two-dimensional motion means the position can be changed in two directions, x and y. As for example, a plane of paper, blackboard, there is a two axis, x and y, carom board. So these are the examples of two-dimensional motion. So the next classification is three-dimensional motion. Three-dimensional motion means the positions will be changed, may be changed in x, y, and z directions. Means space. As for examples, flying bird, then the molecules of a gas randomly moving inside the cube. So there is the examples of three-dimensional motion. So one-dimensional motion is 1D, means one direction, that is linear. Two-dimensional motion means plane, means xy direction. Three-dimensional motion means space, means xyz directions. So now in these topics we will discuss about the chapter motion, especially in the linear motion. Although these are the examples are there, but basically we will discuss about this rectilinear motion. So now go next slide. So now the question comes in rest. What do you mean by rest? If we look around us, we observe that many objects do not appear to move. That means if you see in our surroundings, that means we can find that So many objects are there, do not appear to move. Thus, we can consider them at the state of rest. The objects which is not move or which not changes position with respect to time, then we can say it is in the body is in state of rest. Examples for the state of rest: a book lying on the table will not change its position. That means a book lying on the table will not change its position if it is not disturbed. So it is in state of rest. So number 2, a bench in a park fixed under a tree is at rest as there is no change in position. Is correct. A bench in a mark fixed under a tree, as it is in fixed under a tree, so is it rest, and that's why there is no change in its positions. So if there is no change in position, then we can say it is in rest. Therefore, when the position of a body with respect to surrounding does not change its time, the body is said to be rest. So from these two lines, from these two examples, what we can conclude that the position of a body with respect to surrounding does not changes with time. So if it is not changes with time, then the body is said to be in rest. Next. So now the definition of rest in physics. So whatever the things we have learned in earlier page, earlier slide, we can conclude here. As a definition of rest in physics. In physics, what do you mean by rest? Simple. A body is said to be in rest if its position does not change with respect to its fixed point in its surrounding. Or you can say a body is said to be rest if its position does not change with respect to time, with respect to surrounding, with reference to the surroundings with time. A body is said to be in rest if its position does not change with respect to surroundings change in time. So examples of the state of rest are tools lying on the floor, bench in the park, books on the table. So these are the examples of state of rest. Motion. Unlike the above, we find that so many things around us move from one place to another. Can you give an example? Yes, these are the examples are there. A flying bird is moved one place to another. A moving bus is also moved from one place to another. A boy playing a football. An oscillating pendulum of a wall clock. A moving train. A sailing ship. A walking man, etc. Some of the examples of motion. So these are so many examples are there, but I have listed here a few so that you can understand. So these are some of the examples of motion. So now reference point is very important. There is a reference point. What do you mean by reference point? Reference point means stationary objects. The object which is in fixed is called a stationary object, and stationary object is known as reference point. Suppose this is object, this object is moving with respect to this object. So this object is a stationary object and it is known as reference point. So stationary objects from which motion is observed. So motion is observed. The motion is observed from where? These stationary objects. So from these stationary objects, this motion is observed. So that's why this point is known as reference point or origin. The direction of an object's motion can be described with the reference direction such as north, south, east, west, up or down. From here also you can understand the motion. Motion we can describe. Motion we can observe from the stationary object. So from stationary object, the motion can be observed. So this point is known as reference point. So this is the stationary object. Stationary object is known as reference point. Next, examples for motion. Very simple. When a moving car changes its position with respect to a tree means stationary object, or a lamp post, which is also stationary objects, by the side of the road, the car is said to be in motion. So this is an example, one of the motion. So this is an examples of motion. What is the first example? When a moving car changes its position with respect to a tree or a lamp post by the side of the road, the car is said to be in motion. Number 2, a flying bird is also said to be in motion. Why? As it changes position with respect to stationary object. Which one is stationary objects? Such as trees. So trees are here and the birds are flying. So this, from this stationary point, these birds are in motion. We can consider the birds are in motion as it changes its position with respect to its stationary objects such as trees. So from these two examples, what we can write? We can write when the position of the object or body changes with respect to its surrounding with time, the body is said to be in motion. When the position of a body with respect to its surrounding changes with time, the body is said to be in motion. The body is said to be in motion when it changes its position with respect to its surrounding with time. The body is said to be in motion. So this is the definition of motion is given here. So now the examples for the state of motion. Flying bird means it changes position. Flying bird means it is not in rest in one position. That means every instant of time its position is changes. Sea surfing, high speed train, snowboarding, a boy playing a football. That means all these are examples of state of motion. Playing football, This is the one more examples of state of rest and motion. Now the next is rest and motion are relative. Very, very important terms is here. Rest and motions are relative. Earlier we have learned a body can be rest or a body can be in motion. But here we will be learned here a body can be both at rest, both in motion at the same time. So now the question will become how it is possible at the same time a body, how it can be at rest and in motion at the same time. So now let's see. Suppose you are lying on your beds. Suppose you are lying on your bed. That means you are in at rest in relation to all other objects inside the room. As you are lying on your bed, that means you are in rest inside the bedroom. Your position is rest inside the bedroom. But the room or home is on the earth, is on earth. And the earth itself is not at rest. The earth is revolving around the sun. So thus along the earth you are also revolving around the sun. Hence in relation to the sun you are in motion. That means in simultaneously you are in both rest and motion. If I compare it with a bedroom, that means you are in rest. And if you compare it in relation with sun, that means you are in motion. So that's why rest and motion are relative. So that's why it is written as a body can be both at rest and motion at the same time. So at the same time, when you consider in the bedroom, with respect to bedroom, then you are in rest. And when you compare it with relation to the sun, then you are in motion. Now next, consider a boy sitting on a bench in a park and looking to a bus passing by on a road. So for the boy, the bus is in motion, but the trees in the park appear to be at rest for this boy. But to a boy sitting inside the bus, to a boy or girl sitting inside the bus, the trees and boy outside the bus will appear to move in the opposite direction. And the roof of the bus, driver of the bus, will appear to be at rest. That means same thing simultaneously at the same time can be happen. If you are considered, means you are in the park, that means you are in rest in comparison to the trees. In relation to the trees, as trees are in rest and you are also sitting on a bench and you are also in rest, that means you are in rest. But when the others object But for in other case, those who are sitting inside the bus, for him you are in motion. You are in motion. So that's why both motion and rest are in relative to each other. Now the next point, if two trains move at the same speed in the same direction on two parallel railways, then what happens? It's a common example. Two trains move in the same direction, same speed in two parallel railways. Then what you feel? You feel that always trains are stationary. Trains will appear as stationary to the passenger sitting in them. Okay. So now what we have learned? We have learned motion, we have learned rest, we have learned examples of rest, examples of motion, reference point, and motion and rest both are relative. And remember one point, in this universe nothing is absolutely rest. Everything is motion. So now in the last, what is the difference between rest and motion? So those the students those who have understands about the meaning of rest and motion, they can easily write down the definition of rest. Means the body which is in rest with reference to the surrounding with time. The motion, a body set in motion, if it is changes its position with reference to the surrounding with time, then we can say it is in motion. Examples is here, a book lying on the table, a flying bird. As an examples of rest and motions. Okay, thank you. Today is this much only. Thank you to all.